Okay, so we're going to be doing the integral of 1 over x squared plus 3 raised to the power of 3 halves. So whenever we have x squared plus some constant squared, we need to bring in a trig substitution, specifically a tangent. And this may not seem like it's squared because you don't often think of 3 as something which is squared, but it is. It's just square root of 3 squared. So to show you what I'm talking about, a trig substitution, there's x equals a tangent of theta. You can have x equals a secant of theta, or x equals a sine of theta. And you use all of these in different situations. Whenever you have something squared plus something else squared, which is a constant squared, you use the a tangent of theta substitution. You let x equal whatever this is, but not squared. So in other words, square root of whatever you have here, let that equal a, and make that substitution. So in other words, you have something here of the form x squared plus a squared. X squared plus a squared. So a, in our case, is going to be root 3, because that's what a is. Now we can go ahead and make that substitution. But we also need the derivative, because we're going to have to replace dx with d theta whenever we make a substitution in this form. So the derivative, dx, is root 3 secant squared theta d theta. Okay, now go ahead and make that substitution. So we have root 3 secant squared theta d theta over root 3 tangent theta squared plus 3. And now remember that this just means you're taking the square root and cubing it. So we could go ahead and do that. Or for simplicity's sake, we could just leave it as it is. Sometimes I just like to leave it as it is, so I think I'm going to do that actually. It is just to the power of 3 halves. Now we notice that what's inside, first of all, actually apply the squared. Apply the squared here. So we have root 3 secant squared theta d theta. Apply the squared, and you're left with 3 tangent squared theta plus 3 all to the 3 halves. Okay, now this is perfect because notice that this is one of the trig identities. Whenever you have tangent squared plus 1, you can make that substitution with secant squared plus 1. In this case, it's going to be cubed and then square rooted, but it's still the same. Still the same situation. So we have root 3 secant squared theta d theta, and here we bring out the 3. We bring out the 3, and we're left with tangent squared theta plus 1. And this is all notice it's all still to the power of 3/2. So you can't just bring out the 3 magically and have like 1/3 over here. No, this 3 is to the power of 3/2. But you can still make the substitution here of secant squared theta. Secant squared theta. This is to the 3/2 power. So now we can bring that out. We can bring out √3 from the top and bring out 3 to the 3/2 out of the integral. What we're left with inside is secant squared theta over secant squared theta to the 3/2. So what that gives us is just secant cubed. It's secant cubed because you have something squared, you take the square root of that by the 1/2, and then you cube it. So this is actually all just secant cubed of theta. Secant cubed of theta. Now, secant squared theta over secant cubed theta is just 1 over secant theta. It's 1 over secant theta. And what is that? 1 over secant theta is just cosine of theta. So even more simple. This is very easy in this case. Not so easy, I'm kind of having to think about it. So you have cosine of theta, and now just take the integral of that. Take the integral of cosine of theta, which is, as we should know at this point, it's sine of theta. So we're left with our final answer, not our final answer, because we still have to substitute back whatever theta was. So we have that multiplied by sine of theta plus c. Now, how do we make the substitution back? How do we know what theta was? Well, because we want it back in x's, right? Well, the way we do it is by using whatever we had in the first place. So how would you get theta by itself, given this equation? The way you get theta by itself is you divide by √3 and then use a triangle to find the properties that you need. So let me show you. You have x over √3 equals tangent of theta, right? Simple algebra. Now, we need a triangle. Remember that tangent of theta equals opposite over adjacent. That's something from our high school days, from geometry. Opposite over adjacent. SOHCAHTOA is this mnemonic that we use. T standing for tan, TOA. OA, opposite over adjacent. So we draw a right triangle. That's a very bad triangle. A right triangle. We make theta, this angle right here, opposite over adjacent. Now, we're looking for sine of theta. What was sine? SOHCAHTOA, remember? OH, opposite over hypotenuse. So opposite, which is x, over hypotenuse. So sine of theta equals opposite, which is x, over the hypotenuse. The hypotenuse is this. The way you get this is the only one we don't have, but it's easy, the Pythagorean theorem. It's 3, whatever you have here, squared, plus this squared, square rooted. So in this case, we have 3 plus x squared, 3 plus x squared, square rooted. So that's this. So our final answer is, once we substitute it back over here, is going to be root 3 over 3 to the 3 halves sine, and we found out that sine theta is x over root 3 plus x squared plus c. Now it doesn't look very pretty, but that's the answer.